Scene script. Have you ever wondered what could power our ambitions to explore the farthest reaches of our universe? As we strive to push the boundaries of human exploration, the need for a reliable, efficient, and potent power source becomes paramount. The answer to this cosmic conundrum, you ask, it may just be nuclear power. Now, we're not talking about the nuclear power that's associated with mushroom clouds and atomic bombs. No, we're talking about a much more controlled form of nuclear power that could potentially fuel our spacecraft on long-duration space missions. This is where nuclear power, a seemingly old technology, finds its new and exciting application. Nuclear power, in essence, is the use of nuclear reactions that release nuclear energy to generate heat. This heat is then used in steam turbines to produce electricity. In the context of space missions, nuclear power could be a game changer. Imagine a power source that is compact yet potent, reliable yet efficient, capable of functioning for years, even decades, without the need for refueling or maintenance. This is the kind of power source that could propel us to the farthest reaches of our galaxy and beyond. But how does nuclear power work in space? Well, it's all about converting heat into electricity. In a nuclear-powered spacecraft, the heat generated by nuclear reactions is used to produce electricity, which then powers the spacecraft's systems and propulsion. A nuclear power system for space missions is effectively a miniature power station, capable of powering a spacecraft for many years, potentially even decades. So, if nuclear power holds such promise, what could possibly be the roadblocks to its use? Stay tuned as we delve into the benefits and challenges of harnessing the power of the atom for our cosmic journeys in the following scenes. Scene script. Harnessing nuclear power for space exploration could truly be a game changer. But how exactly? Well, let's start with the fact that nuclear power has an incredibly high energy density. This means that a small amount of nuclear fuel can generate vast amounts of energy. For instance, just 1 pound of uranium, which is commonly used in nuclear reactors, can produce the same amount of energy as about 3 million pounds of coal. Now imagine the possibilities if we could harness this power for space missions. It could potentially fuel spacecrafts for years or even decades without the need for refueling. This leads us to the second advantage of nuclear power in space, which is its ability to operate in extreme environments. Unlike solar power, which relies on sunlight, nuclear power doesn't require any external conditions to function. This means that a spacecraft powered by nuclear energy could explore the darkest corners of our galaxy, the places where sunlight is scarce or non-existent. It could even withstand the harsh, cold temperatures of space without losing its efficiency. And then, there's the potential for long-duration space missions. With nuclear power, we could send spacecrafts on missions that last for years or even decades. This could allow us to explore distant planets and galaxies that are currently beyond our reach. Think about it. With nuclear power, we could potentially send a spacecraft to the outer edges of our solar system or even beyond. This is something that would be almost impossible with the current technology that relies on chemical propulsion or solar power. And finally, nuclear power could also enable the construction of permanent bases on the Moon or Mars. These bases could be powered by small, portable nuclear reactors that provide a constant and reliable source of energy. This could open up a whole new world of possibilities for human exploration and colonization of other planets. These benefits make nuclear power a promising candidate, but it's not without its challenges. While nuclear power seems to be the answer to our space exploration dreams, there are hurdles that need to be addressed. One of the most prominent challenges is safety. Nuclear power, as we all know, carries inherent risks. A malfunction or accident could lead to a nuclear incident, which could have severe environmental consequences. The containment and control of nuclear reactions in space is a significant concern. The extreme temperatures, radiation, and zero-gravity conditions in space make it a highly volatile environment for nuclear reactions. Additionally, there's the potential for accidents. Launching a spacecraft is no small feat. It's a process fraught with dangers, and when you add nuclear materials to the equation, the risks are amplified. A launch failure could lead to the spread of radioactive materials, creating a potential environmental disaster. Then there's the issue of weight and size. Nuclear reactors are not exactly light or small. The larger the reactor, the more fuel it requires, and the more fuel it requires, the heavier it becomes. This creates a vicious cycle that makes it difficult to design an efficient and practical spacecraft. And let's not forget about the complex technology required. Nuclear reactors are intricate pieces of machinery. Designing, building, and maintaining them requires a high level of technological knowledge and skill. This complexity also increases the potential for things to go wrong. Lastly, it's important to remember that nuclear power generation results in nuclear waste. While this waste is relatively small in volume, it remains radioactive for thousands of years. With no practical way to dispose of this waste in space, it presents a long-term challenge that we need to address. Balancing these benefits and challenges is crucial to making nuclear power a viable option for space missions. There's no denying that nuclear power has the potential to revolutionize space travel, but we must tread carefully. The stakes are high, and the challenges are many. But if we can overcome these hurdles, the rewards could be out of this world. Despite these challenges, the potential of nuclear power in space cannot be ignored. As we stand on the precipice of the new era of space exploration, nuclear power is becoming an increasingly significant part of the conversation. Ongoing research and development in the field of nuclear power for space missions are making strides towards harnessing its immense potential. From NASA to SpaceX, from Blue Origin to the European Space Agency, efforts are being made across the globe to overcome the challenges and harness the benefits of nuclear power. NASA, for instance, is currently working on a project known as the Kilo Power Project. This project is aimed at developing small, lightweight, and efficient nuclear fission reactors that can provide up to 10 kilowatts of power. This would be enough to power a habitat or recharge rovers and other equipment on the Moon or Mars. Over in the private sector, SpaceX CEO Elon Musk has also expressed interest in nuclear propulsion for his Starship spacecraft. This advanced spacecraft is intended to carry humans to Mars, and nuclear power could potentially provide the necessary propulsion for such a long-duration mission. Similarly, the European Space Agency and Roscosmos, the Russian space agency, have also shown interest in nuclear power for space missions. They are exploring the feasibility of using nuclear power for deep space missions, where the sun's rays are too weak to provide sufficient solar power. In the face of the daunting challenges of space travel, the future of nuclear power in space looks bright. The potential benefits of nuclear power, such as its high energy density and long lifespan, make it an attractive option for powering long-duration space missions. As we continue to push the boundaries of human exploration, nuclear power could become an essential tool in our spacefaring arsenal. The challenges are significant, but the potential rewards are too great to ignore. The future of space exploration could very well be powered by nuclear energy, propelling us to the stars and beyond. In our journey today, we've explored the potential of nuclear power in space exploration. We delved into the crucial need for a reliable power source in the vast expanse of space, where the sun's rays often fail to reach. We acknowledged that nuclear power, with its high energy density and longevity, presents a compelling solution. However, we also recognized the challenges that come with it. We discussed the technical difficulties of designing safe and efficient reactors, the ethical concerns related to nuclear waste, and the political hurdles that come with the use of nuclear energy. We then looked towards the future and the ongoing efforts in this field. We learned about the initiatives to develop new technologies and strategies to overcome these challenges and the promise they hold for the future of space exploration. As we continue to reach for the stars, the promise of nuclear power may just be the key to unlocking the universe's secrets.